by YouTube because it's captioned. I can link to it. Now I want to go. So I have SU. Now, the deal with these is this. Now, I didn't. These are being taped. We're taping right now. And the way that system does it makes a whole flurry of files, a whole bunch of files, and they are processed into fewer files that the MediaSite server will present. That's what I used to link to, but they don't have any captions. So to get them into YouTube format, we need an MP4, and they have to be further processed. And CIT does that for me with an auto process, but they do it late Friday afternoon. So what that means is that you won't see them until the next week. The earliest maybe Sunday, so there might be almost a week between Monday's lecture or Tuesday's lecture and when it's available via this page. Nothing I can do about that. It's just the schedule, CITs, the way they do it. Also, these are not a replacement for coming to class. A few of you will treat it that way. Will occasionally watch a video. There's very high correlation between those who come to class and those who get good grades. Those who don't come to class and those who don't get good grades. So if your goal is, in a year and a half, to step across the interviewer's threshold with a B-, then don't come to class. Look at an occasional video. But if your goal is to step across the interviewer's threshold with an A or an A-, come to class. Okay. There is that kind of difference. I've been taping for 3 years now, and I can tell you there's a very strong correlation between those who get good grades and those who come to class. The only reason I'm including these is that it's useful for you to be able to go back. If you miss something in class, it's useful for you to be able to go back and pick that up. And it's also useful for me. I discovered how painful that was on Friday, my bad typing and stuff. Oh, was that boring, watching me mistype everything. But I still like that interactiveness because if I just presented it, there it is, a blur and nothing much sink in. But if we kind of slowly go through it, then you're kind of processing it as we're talking about it. I think it works a little better. I don't know. But anyway, so there are videos. There will be the video page. So what happens here is that if you just go up here to projects, videos, that'll link to this page. Don't send me an email saying, please, on Thursday, please, I need to see Tuesdays. Please put it up right away. I can't. And there will be times when I'm really busy on the weekend. It takes a little time for me to get them uploaded on the YouTube, partly because I bumble around a little bit. I'm no expert with YouTube. Thank you, Nog. Nog has helped me set it up in the first place. But I'll get them up as soon as I can. Okay. So there will be a help session this Friday, and I expect that we'll be talking about Project 2, and I wanted to talk a little bit about persistence, not much. I've already said an awful lot about Project 2, but definitely we'll talk about requirements, and I might talk a little tiny bit about persistence. Before we start the second part of the value types, let's take a quick look at the grade sheet. Here's how you're going to be judged. Here's how your project will be judged. So it will be judged on structure, on style, on design, and functionality. And the functionality part is 45 points, less than half of your score. So where did that other half go? So part of it is structure. Modular structure means, do you have a set of packages, each package of which has a single responsibility, implements a single responsibility? That's, and are the dependencies reasonable? You know, have you got a decent dependency structure and so on? Public interface documentation means, do you have a prologue, name of the file, quick statement about what it does, 4 or 5 words, your name, and then below that a paragraph of more details about what it does, required files, maintenance history, okay? And your maintenance history will probably say version 1, February 6th, first release. Hidden implementation. That means that A, you don't have any global data, A, you don't have any public data in the class, B, you don't have any public data in class, C, your member functions don't require design knowledge to use. Occasionally you want to write helper member functions that do require design, understanding the design to use. They should be private and just serve as helpers for the public member functions, simpler public member functions that don't require design knowledge. Test stubs appended. Every package should have a main. Every package except the executive should be bracketed by a #if_def test_ package name #if. That way we can switch them in and out with the project statements, with the properties, project properties, and so you can compile and run your packages standalone. And what that, you know, you're going to do that when you develop stuff. If you sit and try to write the whole thing, type. Okay, now I'm ready to test. Big mess. Tears of frustration will be rolling down your face very shortly. I promise you. What you want to do is take a piece and test it, like the queries we talked about. Okay. Yeah, you need the database. So we did the data. You know, there's the database prototype. Now, having that, now you can focus on queries. Do the queries, testing as you go. Add a conditions type. We'll test for the conditions type. Add a query. Select function. Test for the select function. So on. So test stubs. The main, every package has a main, but the executives doesn't need the #if_def test because it's nobody else uses it. It's always going to run. Style. So before I talk about style, let me go down and look at design, and then we'll come back to style. So here's in design. Global variables, it's okay if they're const, but not okay if they're not const. You'll lose 1 point for each file that has global data. Cyclomatic complexity and small functions. So small function says that each function has 50 or fewer lines. That counts white space. That counts comments. That counts declarations. Everything. And so some students' reaction is, okay, let's remove all the white space and remove all the comments so we can get it to be a small size. And so if you do that, we'll come up here to comments and indenting, and you lose points there. Okay? It's important. You look at my code. My code, almost all the functions are less than 50 lines. And they all have white space. And they all have comments, and they're all very readable, most of them. And most of them, if you scan through my code, you'll probably find a function or two every, once in a while that are greater than 50 lines. Not very often. If you have big functions, they're really hard to test. Cyclomatic complexity, that's really a count of the number of open braces in your function. Okay, it's the number of scopes counting the function scope that are included inside your function. That really has a lot to do with how complicated this function is and how hard it is to test. Is it a perfect measure? No. Complexity, Nog's version of complexity is different than my version of complexity, is different than your version of complexity, but it's a good approximation. Now, you don't have to count that stuff. There's an analyzer. I have an analyzer. I'll show you where it is in a minute, and you can run it on you can run my analyzer on your own code. Okay. Piece of cake. Let's go back to style. So we tend not to take points off for style much. Every once in a while. So you want good, meaningful names. You want appropriate use of white space and appropriate use of comments. You could lose a point because you have a function that's doing something obscure and it needs a comment to explain it. Or you have a function that's really simple, very straightforward, not obscure at all, and you put a comment in there anyway. Okay. Ideally, your functions don't have any comments because they don't need them. They're so plain, well-named, obvious, simple, you don't need any comments. That's an ideal function. If you're using an algorithm somewhere, you say, this algorithm came from, if you want to know more about it, things like that. Okay. There's another that says here, design code simplicity. So mostly I use that if I look at your code and it meets all the requirements, but I don't like it. It looks rickety to me. It looks like it couldn't possibly work on anything. If you make the tiniest change in requirements, it'll fail. Then you would lose points for design code simplicity. If you've hardwired a path name, okay, you hardwire a path name using an absolute path, it'll fail because the TAs won't have your directory structure on your machine in the lab on the machines they test on. So you want to use relative paths. Functionality, compiles and links. So if you have warnings, you lose a point. Runs reliably. If you throw an unhandled exception, 5 points going off the top. You can always, use try-catch blocks and catch exceptions. Now, Microsoft loves to use asserts. You cannot catch an assert because an assert doesn't throw an exception. It immediately calls abort. You get this angry little dialogue, and there's nothing you can do about it. But what an assert says is that there's something fundamentally really wrong. You're accessing memory you don't own, or blah, 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 blah. So, in either case, if you either assert or throw, or an exception is thrown and you don't handle it, you'll lose 5 points. If an exception is thrown and you handle it, you'll probably lose a point or two, but you won't lose 5 points. Because you've got good error handling, and we happen to do something that your code didn't think of. Okay. Meet specifications, yep. Now you have to demonstrate it. Remember, you have to demonstrate you meet the requirements. If you have it perfectly executed and you didn't demonstrate it, you don't get points for it. You'll lose points for that requirement. We won't give them back to you. Your obligation to demonstrate the requirements, that you meet the requirements. So if I'm going to modify the database, what I want to do is show the element I'm going to modify before it's modified, modify it, and then show it after modification. But you don't want 30 pages of output. Ideally, there's 2 pages of output. Maybe. 1 would be ideal. 2 max. So you need to think about, you need to design the test. There's as much, quite a bit of thought needs to go into the design of the test. I've given you quite a bit of help. You know, there's this test utility that I use on the prototype. You see it in action, you know, so you're invited to use it and help you demonstrate to meet the requirements. Reusable modules, usually we won't take points off of that unless you take one of mine and you stuff application-specific code into that reusable module that I gave you. You'll lose points for that because you've destroyed the reusability of that module. Ideally is if you want some different behavior than the code I supplied, you wrap it, you use its internal functionality without change, and then you modify however you need to. Now, the NoSQL prototype, you can do anything you want with that. That was just a prototype. That was not a reusable module that I gave you. It was just a demo, to get you started. So you want to change that all over the place, or you want to do something entirely different, you're welcome to, without penalty, as long as it works. Okay. Code analyzer here. What you want is this code analyzer with GUI exes.zip. You download that and unzip it, and you'll find the analyzer code. There's really two executables. The graphical user interface creates an instance of the analyzer and supplies the command line arguments. The analyzer that I built is driven by command line arguments, and the GUI is just there to make it simple. So the GUI, you go and search for the folder that you want to analyze, the code that you want to analyze, and so on. So you don't need to count function sizes. You don't need to count open braces to figure out what the complexity is. Just run the tool. It'll tell you. It's not so much true for C++. C#, .NET code has a whole bunch of source code files that lie underneath your code. We don't penalize you for code that was generated by the compiler or by the build infrastructure. So you're just getting penalized for your code, but you will get penalized for every piece of code you supply. So if you have a test function, I can't tell you how many times I've had this argument. Somebody has a test function, and it isn't really clear that it's test function. It has this huge function in it, 763 lines or something. Okay, you're going to get penalized for that. So, it's okay. For example, if you name this test file 1, we won't take points off. But all of your functional code is, we're going to analyze, and you lose points for problems with size and complexity. But we won't penalize you for code that the compiler generated. I don't think there's much with C++, so probably none. Project submissions. So this tells you you need to supply a compile.bat. The easiest way to do that is just this one line of code, dev environment, whatever your solution name is, /rebuild debug. Okay. Do not say /build. If you say /build and there is an executable, our compiler won't build it. And if you have a virus infection infecting that exe, we'll get it. So do rebuild. If we see it, a build, not a rebuild, then you'll lose points for the, -1 for a run or inappropriate compile.bat. So /rebuild. We try to be sure that all code is compiled. We've had cases where a student couldn't get the project to work right. So they went to their friend and got their friend's exe, supplied it with their code, okay, So it looked like it was running, but we rebuild. The code has to run, has to compile and run. And if you want to test it yourself, so if you just run your compile.dat file in the normal command prompt, it will fail because the normal command prompt doesn't know where the compilers are. You need to use the developer's command prompt. If you just go down to Cortana and ask her developer command prompt, she'll show you. You click on it, and there it is. And that's what I have attached. This is the developer's command prompt attached to my test bar. So if you run it in the developer's command prompt, the TAs will run your run.bat and compile.bat files in the developer's command prompt. I promise you. So it'll work. The run.bat file is just so that if your code needs command line arguments, or if you want to run more than one exe, you might, for example, find it convenient to supply an argument on the command line that demonstrates a certain number of requirements, and then supply a different argument on the command line that demonstrates different requirements. So you do that in your run.bat file. Don't expect the TAs to supply that. The TAs are going to type in compile, they're going to type in run, put their hands behind their back, and when it's done running, you've demonstrated you met all the requirements without the TAs touching anything. Now, they will pull your code up in Visual Studio, and they'll look at it for the things we were talking about, its structure and reusability and all that sort of stuff. But your obligation to demonstrate you meet requirements. Okay, with that, let's talk about abstract data types. I don't think we did. We didn't do the index operators, did we? This is where we left off. Okay. So index operator, operator bracket. Indexing is a relationship between two columns of things. The gazinta and the gazouta. Goes into, goes out of. Okay. So the gazinta is whatever you put into it, like here, that's the gazinta, and this is the gazouta. Okay. Now, indexing, in C++ doesn't have to be an integer. Doesn't matter. It can be a string in, bool out. String in, string out. String in, end out. In, bool out. Okay. Just two columns of things. There's a one-to-one correspondence. For each input, there's one and only one output. That's all that's required for an index operator. Now, for our class, our string class, it makes sense to use an integer, and we do. So notice that we're returning a character by reference, and the way this works, operator bracket, if n, the gazinta, if n is less than 0, or if len is less than or equal to n, we throw an exception because it's out of bounds. We're trying to index memory that you don't own, beyond the bounds of the array that you've allocated on the heap. And so, and this operator function can't possibly know what to do in that case when you've indexed out of bounds, so it throws an exception. With a message, it says index out of bounds. So it's an invalid argument, index out of bounds, so the type makes sense, the comment makes sense. And in exceptions, there is if I have an exception E, there's an E dot what, and E dot what will simply return this thing. Okay. Now, I have seen good people write, it is absolutely inappropriate to ever return a pointer or reference to private data. Dead wrong. How are you going to index a string? So what's happening here is I am returning a reference from this internal array. But it's a character reference. I can only do that, what I can do to any character. I can assign to it, I can read it, I can write it, but just as a character. A string should be able to do that. So you got to be careful of these generalizations. There's some guys with big reputations never return a reference to private data. They're dead wrong. Well, every time you return a pointer or reference to private data, you ask yourself, is this safe and appropriate? In this case, it's safe and appropriate. I can't take that reference and index my way down that array. I could with a hack. Okay, so now the compiler, so here, now, because I've returned a reference, I can say char ch equals s of 3 equals z. So all of these, so ch and the fourth character in s will all be z, will both be z. Changing assignment. And you say, yeah, but you're writing to a function. What happens when the compiler sees the expression is the first thing it does is evaluates any function and replaces that function call with the return value. So what I'm assigning to is the return value of s of 3, not to the function. Now the compiler, if I pass one of these strings into a function as a constant string by reference, the compiler won't apply this index operator to it. Because the compiler says, oh, it isn't const, and you're returning a reference, so you can change it. It is not going to do the analysis that shows I didn't change it anywhere in this function. It doesn't do that analysis. It looks at one line and says, you can change it, won't compile. So what we need to do is provide an index operator for const, and that's what we do here. So now, the difference is only two things. A, I'm returning the character by value, so I can change that value all I want, and I won't affect the string in any way. And I've put const as a trailing qualifier on this declaration. This promises the compiler that that operation won't change the string that's being indexed. So now, the body of the function is the same, exactly the same, but now I can read it, but I can't write to it. Anytime you supply a non-const indexer, you almost certainly should provide a const indexer. They always come in those friendly pairs. And a compiler will always make the right choice. If it's const, it'll use the const. If it's not const, it'll use the non-const. It doesn't do any analysis about whether you're reading or writing. It just looks for const. Okay, append to char. So in a sense, this is something like the assignment, but I'm just appending a character to itself. So the first thing it does is, this is a plus equal. So plus equal for a string means I've got to take that character and put it on the end of myself. So the function looks at the size and says there's room. If it says there's enough room, if len is less than max minus 1, then I set array of len equals ch and array of len plus 1 equals terminating null. Len plus plus, return. But if it's not enough, then I double the size of the allocation and copy over the characters, append the character I'm trying to append, and the terminating null. Len plus plus. Now, notice that I allocated this in temp, so now I delete temp, and I set array equal to temp. So I'm just making my pointer point to the new memory. Piece of cake. It's important that we doubled the size. Suppose we were reading characters out of a socket. And my default string size is 10 characters. But in that socket stream, there's 50,000 characters coming at me. So 10 is a bad estimate of 50,000. So, but I keep doubling, going up. It doesn't take me too many memory allocations to get to 50,000. 6 or something. If I just kept adding the same amount of stuff, if instead of saying times 2, I doubled it, not doubled it, I kept adding this same constant increment, 10 characters, 10 characters, 10 characters, 10 more, I'd be doing allocation, gazillion allocations getting to 50,000. I would do it 5,000 times. 5,000 memory allocations, okay? Not a good idea. Instead of 6 or whatever it is. Okay, and we invoke it by saying s plus equals a. So I know, the user doesn't have to worry about, is there enough space available? It just silently happens. So this class is silently doing things on behalf of the user in a very reasonable way. Now I'm going to append another string. And so, same idea, only now instead of adding a character, I add a string. I could have used the plus equals. I chose not to explicitly for performance reasons. Because if the string I'm adding is long, that could be a lot of function calls to plus equal 1, blah, 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 blah. Could I measure the performance difference? Probably not. Okay, but given a choice, if without much additional complexity, I can make something faster, I will. So I chose to do it this way. So now I can say s plus equals another string. Now here, I wrote this before I had made the promotion constructor explicit, so this would fail to compile. I need a str here. Okay. I wrote this slide before I decided to make that promotion constructor explicit, and I forgot to pick up. But now send me an email and I'll fix that. Addition operator. So now, look at how easy addition is. Having plus equals, so now I want to say string. Now this time I did it right. I don't know why I didn't do it right on the previous page, but I did it right here. So so here I'm promoting this literal string to a Jim Foster string, literal string, and I'm adding them. So that's what this plus operator does. It calculates the sum, and the sum of the two strings is just taking the second string and attaching it to the end of the first string. So now, string operator plus constring string temp equals contents of this. This is a copy construction of myself into temp. And now, temp plus equals s, the thing I just wrote. So, bam, there it is. I didn't have to write anything, almost nothing. So anytime you have operators like plus or minus, I don't know, minus doesn't make any sense for a string, but for some types it would. You want to provide a plus equals, a minus equals, whatever, okay. Because you get one implemented in terms of the other for free. Instead of writing two things with two chances to get it wrong and have bugs, you write one thing in a little tiny, very, very simple. This is so simple, you're not going to make mistakes here. Unless you didn't get enough sleep the night before, or you missed your first cup of coffee or something. Really simple. Okay. Cast operator. So this is a coercion. I want to provide the ability to get a constant char star, a literal string from my Jim Fawcett string, from str. Okay? And so my cast operator is declared str operator, no return type, str operator, const char star empty. So this const char star is the type that I'm casting to. So if I was casting to some other type, maybe a standard string, okay, I could do that. You wouldn't use both standard string and this. Yeah, you're not going to use this class. I don't use this class. I like it, but I don't use it. You always prefer the standard. But anyway, all my cast operator has to do is return the array, the pointer to that internal array. It's doing as const char star, so it's trying to make it as safe as it can. So it'll natter at you if you try to, change something in that array. It'll natter at you, but so that's what the const char star. And so now I can cast it implicitly. So this implicitly calls this cast operator. There's 3 different forms of explicit cast operator. This is the oldest style. This is the C style cast. C++, and I think C now too, provides this kind of cast. So now, instead of having parens around the type and the argument and the variable we're casting, we put the parens around the argument we're casting and have the type out here. And logically, it kind of makes a little more sense. But you prefer to use the new style. So this is the old style, this is the old style, the new old style, and this is the new style. And the reason, so you should prefer the new style, and the reason is cast operations are very often a source of bugs. And so you say, if you're using one of the old style of casts, you say, how do I find that? Oh, I search on paren. Okay. I get the 4 casts, but I also get the 53 functions that I define. I get every place I got a paren, I'm going to see. So now I have a haystack that I'm going to go pick all the. But if I use this static underscore, all I have to say is search on underscore cast, and I'll find every one of the modern casts and nothing else. Okay. Fantastic. That's a cast operator. Insertion. So this is a stream insertion operator. So OStream operator insert, so that allows us to say standard cout insert the string. So what you'd expect it to do is to keep pushing characters in until it got to the terminating null. That's exactly what we do. So OStream operator by reference operator, blah, 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 OStream by reference out, constant string by reference in, and now I just index through that string. I keep pushing those individual characters to cout. Cout understands how to accept a character. It just doesn't understand how to accept a Jim Fossa string. So we're getting it to accept a Jim Fossa string in terms of what it knows how to do, accept a character. Return out, piece of cake. Now, this has to be a unbound function, a global function. It cannot be a member function of this class, because the guy on the left of operator paren is a standard library thing, something from the standard namespace. If I was going to make this a member function, I would have to make it a member of OStream. Meaning I have to go in and change the OStream class in the standard library. Never do that, ever, ever change the standard library. You would be excoriated if you did that. Excoriated. How do I describe it? How many don't know what excoriated means? No. Reviled, beaten about the head and body, given a pig slip, whatever. Yeah. So it has to be a global function. Now, if Stroustrup had defined this operator to be the other way, if he'd said S into standard cout, then we could make it a member function of our class, but he didn't write it that way. He defined it this way, and so we can't. For life of me, I'm not sure why he did it that way, but he did. So, okay, great. Not a big deal. A slightly more interesting case is extraction. So now I want to get some stuff out of a stream and put it into my string. But I have no idea how long that is. So, I'm going to have to do a whole bunch of memory management here. Tricky stuff, easy to get wrong, right? Absolutely not. Because we were smart, and we already did all the memory management in S plus equals CH. This guy's doing all the memory management, right? So we don't have to do any. By ordering these thoughtfully, we've made much less work for ourselves. We've ordered them so that the basic stuff happens early, and then we use it later on. So now, a couple of things are going on here. One is these insertion extraction operators edit the stream. Leading white space and trailing white space are removed. So we do the same thing with our stream. I say, now, so here's my stream. This is not const, by the way, because I'm going to change as I'm reading out of that stream, I'm changing its file buffer pointer, and so I can't make it const. If I make it const, it'll fail to compile. Not here in my code, but down in the standard library code, because I'm trying to increment a constant stream. So can't make it const, non-const. I can make this const, and no, I can't. No, I can't, because I'm going to change this. This can't be const either, because I'm going to change this. So the first thing I do is, after declaring a character, I say s.flush. It empties whatever was in the string before, because I want to write into it. I don't want to stuff, from earlier history. Now, in into CH. So this, when I extract into this character, it's only going to read a character, but it'll skip over any leading white space it throws away until it gets to a character, and then it puts it in there. So, because I did that, now my insertion does the same thing, strips off leading white space, which we expect. But after that, I may have blanks inside my stream, and I don't want them edited out. So I'm going to use in.get. The get functions do no editing. If it's white space, it gives it to you. If it's non-white space, it gives it to you. So insertions are editing. Get does no editing. We'll talk about this more. When we talk about streams, we'll go over this again. That's the way it works. So now, I chose to terminate on a new line, or if I reach the end. If I reach the end, my stream goes bad, and my stream state goes bad. So if the stream is not good, while CH is not equal to new line, and the stream remains good, then S plus equals CH in dot get. I get the next one. Keep going around. Okay. So I didn't have to do any memory management here, even though I have no idea how long that input is, that stream is. So I have no idea how long to make my string. I don't care, because I'm going to use my plus equal. So here's one good reason why we keep doubling. My stream might be huge. I don't want to do a gazillion allocations. Piece of cake. I'm going to be so easy. Okay, C++ binary operator model. So we're done with functions, all those functions. Just a couple of trailing comments. So let's look down here at the bottom. If I have an operator hat, I don't think there is an operator hat. I hope not, because I meant this to be a meta operator, just any old operator you want. If it's a member function of a class, you invoke it as x.operator of y, argument on the left, y is the argument on the right. But if it's a global function, you do it as operator hat of x and y, x on the left, y on the right, okay? the way it's done. It was a member function, like operator equal has to be a member function. Operator insert cannot be a member function. So that's the operator model. Coercions. Here I'm trying to coerce so that when the compiler sees this expression, he scans it, it says type mismatch. There's a Jim Fossett string on the left and a literal string on the right. Now this will fail to compile because I put explicit. But if I didn't put explicit for the promotion constructor, the compiler would scan that expression and see that it could resolve that type mismatch in a single statement by calling that promotion constructor. Mismatch resolved, and it does it quietly. You don't always want those silent conversions, and so if we use the keyword explicit, then they won't happen. So here, for this to compile, I would have to say str parens around that. Okay. In your email to me, Nag, remind me, and I'll put that this one. Because again, I wrote this before I decided to make that. What's it? Overloading. We've done a lot of overloading here. Overloading of constructors and assignment operators, index operators, lots of overloading. So what's overloading? The compiler treats this function by the name string int. It's not string to the compiler, it's string int. And this function is string const string reference. And so there are two different names, two different functions, business as usual. So overloading, the compiler handles in a very simple way. It mangles the names by taking the function name and each of its arguments in sequence. It would treat a string of, I don't know why you'd say, let's say class X, it would treat X int double differently than X double int. X int double would be one function, X double int would be another function. Because the ordering of the parameters is important. It will not overload on return type because the users are not required to use the return type. They can discard it. So if the user discarded the return type on an overload on a function that was overloaded only on the return type, how would the compiler tell which one to pick? Couldn't. So it won't compile your code if you have functions that are just overloaded on return type. But if I put const, it can't be on those constructors, but here, where I put const, this is counts as, so now this function to the compiler is operator brackets int const. This function is operator brackets int without the const. So you can overload on those and will and should be able to overload on those trailing consts, those trailing qualifiers, but not on the return types. Nothing over here on the left because you don't have to use it. Okay. Constantness. This statement guarantees that S will not change. It says nothing about this str. And of course, because this is a constructor, it's obviously going to change. It didn't exist before, now it exists. But this is a contract that, this const is a contract that S won't change. This const is a contract that the instance that indexes won't change. Different. This trailing const is a contract that the instance using that function won't change. Const on an argument doesn't say anything about the instance that uses the function. It's talking about the const of the argument. Right, Nav? Okay. What's your name, young? What did you tell me? So you have an English, oh, what's your, Jessica, right, Jessica? Yes, yes. I won't make you sigh by trying to, mispronounce your name. I've been told, Dr. Chen tells me, don't try to use Chinese students' names because they get really annoyed hearing their name mispronounced so often.
No, I'm not.
Huh?
I'm not.
You're not? Okay, good. I like to use your name. It's your name. I like to try to use it, but I don't do it any better than anybody else. One last slide, C++ expression model. This just says that when I have an expression that involves things like functions, the first thing that happens is those functions are evaluated, and if they have a return type, the return type is placed at that position in the expression, and then the expression is evaluated. So when you're reasoning about the way and what an expression is going to do, you have to understand that functions are called first. Okay. So yeah, hey, conclusions. Hey, we're done. So you now know very well how to design a basic class. I've shown you everything. I've given you a model for everything you have to do. Now, this class has a pointer to an array on the heap. So we had to provide a pantheon of constructors, a number of constructors, and assignment operators, move and copy assignment, and so on. The compiler-generated ones won't work because compiler-generated construction and assignment will just do member-wise construction and assignment. So assignment of a pointer is just making a copy of the pointer, got two pointers pointing to the same thing, bad news. But if your class has just primitive data and or a standard library container type app or something, you don't have to write that. The compiler-generated member-wise operations are perfectly correct. If your class has bases, classes it derives from, and holds on to, contains members, both of which, bases and containments, have correct copy, assignment, and destruction semantics, you don't need to supply those operations in your class, and you shouldn't. Let the compiler generate them because they're perfectly correct. Compiler. Now, when the compiler does a member-wise assignment, for example, those are not shallow operations. I've heard a student say, oh, but the compiler generator does shallow operation. That's incorrect. The compiler does whatever that type does. So if the type knows how to copy and assign, there'll be deep, and it needs deep copy and assign, there'll be deep operation. The compiler-generated operation will be deep copies and deep assignments on those members if they need, because they provided it, as long as they have correct copy, assignment, and destruction semantics. You don't need to do it. So there's a rule of threes. Three things: construction, assignment, destruction. Three choices. Let the compiler implement them. If my bases and composed data members have correct semantics, if my bases and all my data members have correct construction, copy, and destruction, correct construction, assignment, and destruction semantics, let the compiler do it. That's one choice. Another choice is you implement them all. The third choice is you don't implement any of them, but you mark them as delete. copy, you declare a copy constructor equal delete. Declare an assignment operator equal delete. And what that does is that will fail, the compilation will fail if you pass that, an instance of that by value, for example, which requires a copy. The copy is deleted and you get an error message that you're attempting to invoke a deleted function. When would you do that? If you, we'll see when we talk about threading, I have a class that uses a critical section, not a critical, a condition variable. Condition variables are not copyable. And so my class isn't copyable, so I make it delete. Okay. Rule of threes. Instruction, assignment, destruction. Let the compiler do it, I do it, make them delete. Those are your choices. And it all hinges on the first choice between let the compiler do it or is correct copy, assignment, and destruction semantics in the bases and all my members. The or is I do them all. Or if I don't want to or can't, because I hold a member that can't be copied, for example, then I make them delete. Rule of threes, remember it. And if you go up here to notes, classes, at the bottom, rule of threes. So how do we get here? We went to notes, classes, rule of threes. Okay. So let's review this operator model just a little bit. So let me use the PowerPoint. So we already saw this slide. So operators can be described algebraically or by function calls. These generate absolutely identical code. Doesn't matter what you do. This is a little easier, easier to write and easier to understand. And if the operator is a member function of a class, we write it this way. Operator at of y, where this guy is the instance of the class. If they're a global function or an unbound function, that means the same thing, then it's global operator at of x comma y. Indexing operators should usually come in pairs, a non-const and a const. Second form allows you to pass an indexed operation, index object into a function by const reference and still be able to read index values. I haven't talked about, there was no reason to provide these operations for the string class, but things that act like pointers or other objects typically get indexed. And we'll provide index operations. Now, what's going on here is operator plus plus increments the pointer and then uses it, okay, this pointer. So operator plus plus of int increments the operator but uses it before it's incremented. So here, operator plus plus with no argument increments then uses. This operator plus plus with int uses it before it increments. Now there's no way to do that in this increment operator except by trickery. Because as soon as we return with this function, it's done. Okay? So what these do is, notice that what this guy does is plus plus this, the model here is that anything that you're incrementing down internally has a pointer. And so you're incrementing. A smart pointer does these kind of things, for example. So here, what this says is that I'm going to increment this pointer, and then I'm going to use it. Just select. But with this guy, I can't do that. So here's what I do. I say temp equals contents of this. That's my current value of the pointer. I increment it, okay, and then I return this pointer. So I'm returning the old one to be used. I've incremented it, but I've returned the old one before it was incremented to be used. So that's what these functions do. This one increments it, and then it returns that, that object that's acting like a pointer, a smart pointer. So what this means is that post-incrementing, two comments. One is that post-incrementing always creates a temporary. So if you just want to increment it, you're not using it, you just want to increment it, always pre-increment. Because why make that temporary and then just throw it away? The second thing is, this int is crazy. What's that int? That's a band-aid. That's a syntactic band-aid. Strauss-Strip couldn't think. He would have to add another keyword to the language, okay, to tell the compiler, I want this to be a pre-increment, I want this to be a pre-increment, I want this to be a post-increment. So this int just says this is a post-increment. It has nothing to do with anything. It's never used. It's just telling the compiler this is a post-increment. So only supply it, only use it when you see that variable, my smart pointer, post-increment. If you see my smart pointer pre-increment, use the other one. That's all. Usually, it's library writers that do this kind of stuff. Usually, it's library writers that are creating smart pointers and stuff. Every iterator, we haven't talked about them a whole lot yet. We will. And all the STL containers supply iterators. My classes often supply iterators. These things are used by the library designers. Probably not by you. There's not much reason for you to go and write a smart pointer class because there's a standard unique pointer and a standard shared pointer that are smart pointers. Basically what they do is what they point to, they delete. When the pointer goes out of scope, they delete automatically, so no memory leaks. And what happens with a unique pointer is that if I assign this unique pointer to that unique pointer, the underlying pointer is given to this guy like a move operation, and his pointer is set to null pointer. So that he transferred ownership to here. Ownership of that underlying pointer to here. Shared pointer makes another reference to, and it's reference count. So the object that the pointer points to is never deleted until the reference count goes to 0. Every time you do an assignment, it gets incremented, and every time you call delete on it, it gets decremented. Some operators Arithmetic operators should come in pairs. Addition looks like this. X colon colon operator plus const x by reference, x operator plus const x. So we did plus equals and then plus. And we implemented plus in terms of plus equals. Just like we did for the string class. So we get 2 for the price of 1. We write all of the hard stuff here and just a tiny trivial little wrapper around it. So if there's going to be bugs, there's only one place to look. Addition should be implemented this way. Operator plus, create a temporary with a copy construction, add the component to temp, and return the temp. Overloading arithmetic operators. So you define operator plus, operator minus, operator times, and operator divide in terms of operator plus equals, minus equals, times equals, and divide equals. You know, and of course, for a string, the only thing that makes sense is plus and plus equals, so we didn't provide any of the others. But if I were building a complex class that had a real and an imaginary part, come on, remember your physics. Even you computer science guys had a little physics back at your complex variable, you know, real and imaginary part. Imaginary and real part, I'm doing it the wrong way. Okay. So I'm doing it the wrong way. Real and imaginary. Okay. So I would have plus equals, minus equals, and it's even possible that I would have a times equals, because I might be asking for the magnitude. Binary operator model, operator at y is x dot operator at of y if it's a class member. X at y is operator of x and y if it's a global function, if it's an unbound function. Insertion, the insertion extraction operators. This is never const because we're changing the stream. The file pointer or the pointer in the stream is moving as we put things into or take things out of the stream. We'll see all that in detail when we'll talk about IO streams fairly late in the course. You know, the C++ survival guide gave you a real quick shot, you know, and you're using stuff and you're looking it up, I hope, in, you know, cplusreference.com and stuff if you don't, but we'll talk about it in detail later in the course. So these are non-const, and returning them allows me to cascade them so I can say insert, 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 insert in one expression. That's why I return OStream by reference and iStream by reference. And since the streams out and in appear on the left side of the operator and are not objects of the X class, we must use the global function shown at the top of the slide, this function. Okay. Operator on the left, cout. Operator on the right, myString. You should try to implement them without making them friends of the X class. You may need to implement public helper functions to do that. So I had the index operator in my string class, so I didn't have to make them. What declaring something as a friend does is a class can declare an instance of another class or just a function of another class or a global function as a friend. And that means whatever was granted friendship can access the private data of your class. Without qualification, they get added. You try not to do that. You're not breaking encapsulation, but you're stretching the encapsulation boundary to include the friend thing. That's the one. And you want those encapsulation boundaries to be as small and self-contained and local as you can make them. If you don't, it's an opportunity for bugs because, gee, oh, I forgot, that's a friend, oops. But sometimes there's no other way. You don't want to make, so if the operator needs access to private data that isn't normally part of your interface. If you have a question, ask yourself. Should I provide a public interface function so that I don't have to make that guy a friend, or should I grant friendship? And if that public member function would be dangerous, then I would choose friendship. If it isn't dangerous, I would choose to make it a public member function. And you know, danger is in the eye of the beholder. It's a decision you have to make. But the dangerous meaning, can my data be corrupted if I do this? That's dangerous. The data I'm trying to manage. Okay, so we've been through abstract data types, value types. Now you know how to design classes. You do. So from here, we're going to talk about templates starting on Thursday, just in the nick of time, because you got to submit. Okay. A template. Now, we were using the easy part of templates. With templates, there's an easy part and a hard part. And the easy part was what we used. The hard part is template type inference, understanding what's going on there. And we'll be talking about that on Thursday and again on the following Tuesday. After templates, we're going to talk about inheritance and structuring compound objects. And when we're done with that, we've done most of what we need to do with the language, other than provide you some examples along the way. I need to talk about functors and lambdas a little bit. My game plan is to spend a little time this Friday, on the Friday Help session, talking about functors and lambdas. But I'll also talk about them in class. I will probably talk about them the second day of templates. So Thursday will be the first day of templates. On Tuesday, we'll do the second day of templates. I'll probably talk in class about functors and lambdas, because they're used a lot with templated classes in the standard library. They're very useful. I use them all the time. I actually, in the help session code, the code for the second session, I didn't do it for the first session because I didn't think of doing it. Let's go up here to directories, 687, code, what happened to code, where did my code go? Code, project 1, help spring 18. Oh, this is on this machine. Let me go to .687 OD code. Project 1, help spring 18. Help 2. Help 1 was code I wrote in the first session. Help 2, so here's help 2.cpp. So what I did here in my little tiny oh, that must have been in help 1. Sorry. First session. Help.cpp. Here we go. So here I had the select function, the query, select taking conditions, and query from keys, query show, query keys, blah, 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 blah. But there was a template type named T, query by reference select T. This is a non-template class, but it has a template member in it. And what's going on here is, this function is here so that I can supply a lambda or a functor to that select function that does some custom process. So it isn't one of my can queries, it does some custom processing. Maybe I want to delete an element with a query, I can do that. That's why that's there. So what's happening is, this is here expecting that the user will supply a lambda. Almost certainly he'll use a lambda to define that custom quickly, a little bit of processing I want to do. I want to delete every element whose name begins with J. Because I got a grudge against all the Jims, okay? So, or something. All righty. I think we're done for the day. I'm certainly done for the day. Peek ahead at the template stuff. The more you read about it, the better, the more easily you'll grasp the stuff we talk about. So, you can look at the presentation, you can look at the class text. And as we said at the beginning of class, there will be a help session on Friday. So, see you all then. You don't want to do that. If you pass, this is a copy constructor. So if I pass the string by value, guess what? That calls a copy constructor. Which needs to call a copy constructor. Which needs to call a copy constructor. Which needs to call a copy constructor. Go to constructor, click down, and change that to a by value. And you'll see it'll flow the stack. So what I always favor if I can, because instead of copying, doing all the stuff. Yeah. Yes, you have to demonstrate.
要我跟你去哦，10点半。
那你一会儿直接。
何老师，我的那个何老师，一会儿7点，如果会7、8点，何老师这样子。不在啊，刚才。